Alright, so I'm going to review the top 10, or actually top 11 most missed questions from the Quizstar for thermodynamics, so this should help you. So things you should focus on. First thing we talked about was the first law of thermodynamics, which is Q plus W equals internal energy change. This question, there was a mistake in the question I told you in class. I think this was the issue. It was supposed to be which one is incorrectly associated. It said correctly, but I told you guys to adjust it, but maybe you guys didn't hear me. You do need to be aware of the signs, and then you add the two values together to get the total change in energy. It's like your energy account balance. So if you notice Q, if heat is added to the system, Q is positive. That's endothermic. That's correct. If the system gives off heat, that is correct. Now, if work is done on the system by the surroundings, it has a positive value for W. D is correct. If work by the system on the surroundings, if it's done by the system, that has a negative sign. So that is why C is incorrectly associated. So you need to know those values. Heat going in or work done on the system is positive for either Q or W. Heat given off by the system, exothermic, is negative, and work done by the system would be a negative sign, and then all you do is add the two values together. All right, next one, heat is a conversion factor. You guys had a couple questions on this. We did one of them in class the other day. Remember, if I ask you how much heat is released, calculate the delta H released, and you notice that there is an equation here. All it is stoichiometry. Instead of the turkey that you put in a normal stoichiometry one once you get to moles, this one you basically put the heat value in. So your given is 89.6. I put 89.6 grams of SO2 there. Molar mass of SO2 is 64 grams of SO2. Is equal to 1 mole. Once I get to moles, then I need heat as a conversion factor. If you look, SO2 to the heat reaction, that is a ratio. One of those gets you negative 99.1 kilojoules. So I make a conversion factor out of it. You see right there. When I fluffy bunny this, fluffy bunny, I am left with heat. Multiply across, and you get negative 139 kilojoules and divide by 64, obviously. So when it asks you how much heat is released, remember released means a negative sign. Absorbed would be positive, but in this case they included the negative sign on the answer choices. Heat is a conversion factor. You'll definitely have to be able to do that on the exam. Which substance has a heat of formation of 0? Remember when I asked you to do a table value, products minus reactants, all elements have a heat of formation of 0. They have to be elemental in their state. What's wrong with these other things? Well, this is a noble gas, so as a liquid, it would not have a heat of formation of 0. Sodium is a metal, which is normally a solid, so that's technically not elemental in form. Nitrogen is a gas, which means that's not elemental in form. At room temperature, oxygen is the correct answer. Oxygen is a gas at room temperature. So it's elemental, normal elemental state or form. They have a delta H value of 0. Next one. This is asking you for this reaction, at what temperature will K be equal to 1? At the end of the thermodynamics lecture, I told you be aware of this, the K values and what they mean. When K is 1, you have this table in your notes, that means delta G is 0. And we talked about that. If you take going home to supper and you set delta G to 0, trying to find a temperature for when something will go from spontaneous to non-spontaneous or the other way, it's just T is equal to delta H over delta S. So all you have to do to solve this problem is you're going to take the 128 on top. So you're going to take the 128.9 kilojoules on top. And then you're going to take this. S has to be changed in the correct units. 0.321 kilojoules on the bottom. And then you get your value. Bam. A right there. Things you have to remember. If KQ is 1, delta G is 0. It means it's in equilibrium. If delta G is negative, if the reaction is spontaneous, it means it's going to go forward. Therefore, K is greater than 1. If delta G is positive, that means K is less than 1. Yes, you definitely need to know that. You also need to be able to use going home to supper to solve for temperature. So when they tell you delta G is 0, that's when it goes from being spontaneous to non-spontaneous, because obviously negative is spontaneous, positive is non-spontaneous. Anyway, so here we go. Next one. This is the formula for relationship between equilibrium and delta G. In this case, I give you the equilibrium value, 7.0. I plug it in there. R, it is a different R. So that's where most of you guys are making your mistakes. This is the R for heat, 8.314 joules. T is temperature. They tell you what it is, 35 degrees Celsius. So you get 308 Kelvin. You pop that in. When you do your calculations, you end up getting negative 4982.9, but that's in joules. So you get negative 4982.9. Because this is in joules, that answer spits out in joules. So then what you have to do is you have to adjust it to kilojoules. You just divide by 1,000 and you get your answer A. Definitely have to be able to do that on the test. Remember, if I give you a delta G value, which I just might, you have to blow it up to joules because delta G is normally in kilojoules. When you use this equation, because of the R's in joules, delta G, when you go to do your calculations, must be in joules and then adjusted at the end like in this one. But going in, if I gave you a delta G of 79, you would change this to 79,000 if you were trying to solve for KEQ. Let's see here. Next one. Which of the following shows the greatest increase in entropy? Well, let's look first of all. Liquid to a solid, using the SLG rule, that can't be it. Liquid to a gas, yeah, that happens for 1 mole. Liquid to a liquid, that kind of cancels out and you get half a mole of gas. Close. But look at this. This goes from 1 mole of gas to 3 moles of gases. So then the inference is, since you're going from 1 mole to 3 moles of gases, that's a large increase in entropy. You're looking for the greatest increase in entropy. So you use the SLG rules, but if there's a huge difference, like in the case of gases going from 1 to 3, that is going to be the largest increase in entropy. Next one. Which statement is true concerning entropy? Well, if you look, an exothermic process, the definition transfers heat from the systems to the surroundings. So when we talk about the system, exothermic means that heat leaves the system. So that is true. Endothermic process absorbs heat from within the system. That's not true because the heat comes in from the surroundings into the system. Endothermic process increases the entropy of the surroundings. That's not true. Exothermic process results in a decrease in the entropy of the surroundings. That's not true because if you use the SLG rule, think about this way. Exothermic process does not really result in a, doesn't affect, it's a change in heat. It doesn't really affect the entropy of the surroundings anyway. Next one. This one, it's asking you vaporization of water at 50 degrees Celsius. First of all, does water vaporize? It doesn't mean evaporate. It's saying, does water vaporize at 50 degrees Celsius? It does not. It does not. It vaporizes at 100 degrees Celsius. So since it is not spontaneous, automatically I know my delta G is positive. Right there. I know that's because it doesn't happen. Water does not vaporize at 50 degrees Celsius. It vaporizes at 100. Next question. Next part. What's the delta H for it? If you're going from a liquid to a gas, delta H and delta S are the same using the SLG rule if you're talking about a substance that's changing states. So if you're having water going from a liquid state to a gaseous state, you know that delta S is positive using the SLG rule. So delta S is positive, right? Delta H is also positive because in order to change states of a substance, what you have to do is you have to add kinetic energy or heat, which increases the distance. So if you're going from a liquid to a gas, the delta H value is positive as well. So that's why A is the correct answer. That's applying what you know about basically about the real world or the natural world to chemistry. So the fact that heat is required to go from a liquid to a gas, it's the SLG rule. You know if you're going from a liquid to a gas, the delta S is positive as well because entropy is increasing using the SLG rule. And then you know that water does not vaporize at 50 degrees Celsius. That's just applying what you know about water and what you know about the natural world. All right, this is asking you if this is stable. When they ask you questions like this, giving you an H and an S, they're asking you, will the reaction occur? The top of the thermodynamic mountain, the monk, the top of the mountain. Is it spontaneous or non-spontaneous? If it is spontaneous, the reaction will go forward and occur. If it is non-spontaneous, that's where you have to add energy. Well, look, I have an H that's negative. So I have a negative H. and I have an S that's positive. They're not asking you to do any calculations here. They're asking you, is it stable? If it's stable, it's non-spontaneous. If it's unstable, it means a reaction will occur, and that is the condition of always. Negative H, positive S is always. We say it is not stable. Hydrogen peroxide will break down into water and oxygen gas. It is a spontaneous reaction. Next one, asks you to calculate heat of reaction. Notice the little F as a subscript is heat of formation. Remember, when you're doing any formation, it's going to be products summed together, reactants summed together, and then you subtract them. Make sure you use the stoichiometric coefficient. So I start with the products. CO2, value is negative 393.5 right there. Coefficient's 1. I have that. Water, the value for water is negative 285 right there. Coefficient for water in the equation is 2. I multiply that by 2. I go to look for oxygen, but remember, elemental things are 0. That's why it's not included in the table. Don't fall for that on the test tomorrow. Then I take CH4. The value for CH4 is negative 74.8. Put that right there. Coefficient's 1. You go through and you do your calculations, and you get a delta H value of negative 889.7 kilojoules. 25. They asked you, will this reaction happen? What they're saying is blank will it happen or it won't happen? That's, again, spontaneity, delta G, the top of the mountain. So what you have to do is you have to basically do what we did before. You do products minus reactants for delta H using the reaction. So here's the reaction right there. You do products minus reactants. You find your delta H. Pop that into going home to supper. You do the same thing for S. You take all these values, products minus reactants. You pop your S in. The temperature is 298. You pop that in. You will get a positive delta G value. When you calculate this, you get a positive delta G, which means it is non-spontaneous. So the reaction will not reduce or not happen because it is non-spontaneous, so the correct answer is C. And there you go. Those are all the most missed questions from the test. Everyone else did really well on all the other questions. Make sure you study, review. I will also be sending out a packet of the objectives so you can review the objectives. If you need more practice, I would go back over the homework assignments in the chapter, look them over, and then just make sure you know, especially things like this. There are some questions on the test that look like this. Right here, using this table right here. Make sure you memorize it, and make sure, I believe it's like question 20, 21 in chapter 17, where we had to do, you would find the S by looking at it, and they gave you the H, and you had to tell me what temperature it would be spontaneous. There's a couple of those questions on the test. All right, see you tomorrow. Have a good rest of your weekend.